Okay, so all right, so starting with this question. It is a 2017 paper. Question 1. Hope everybody getting okay. I'm gonna save that person to that thing. Hold on, just give me a second. Oh Lord. And restart the recording. I don't want that one to be the main one. All right, let's know. All right, so let everybody coming in now. So let's see. All right. So starting with this question right here. All right, you work it out on the right side here. All right, so question says use a calculator otherwise to calculate the exact value of this thing. But the important thing here is that we have to work out what is in the bracket first. All right, and then remember that when you divide by a fraction, you can invert and multiply. So first you want to do is get rid of those mixed fractions and write them as improper fractions. It's kind of easy when you do it that way. Suppose 3 is 12, 12 and 1 is 13, so that's 13 over 3, minus 5 1 is 5 and 2 is 7, so that's 7 over 5 in the bracket. And then we're going to multiply by the reciprocal, which is 15 over 4. So invert and multiply. All right, that's what we need to work out this thing in the bracket. So we're adding fractions that are unrelated. They're unrelated because the denominators aren't the same. We want to make them related. You can adjust the fractions to make the two denominators the same. So what you can do is multiply this fraction by 5 over 5. So you multiply basically by the denominator of this one. And you multiply this fraction by 3 over 3. So you're multiplying this one over here. So it's basically essentially like you're multiplying by 1 because 5 over 5 is 1, 3 over 3 is 1. So the two denominators will become the same, right? And so now, the 5 times 13 is 65 over 15, minus the 7 times 3 is 21, also over 15. And that will become one fraction. We multiply now by 15 over 4. Then the 65 minus the 21 is actually 44. So this here becomes 44 divided by 15. And you're multiplying that by 15 over 4. And so this 15 cancels into this 15 one time. And then the 44 cancels with the 4 11 times. Alright, and so that becomes 11. So the exact value there is 11. Alright, that's the first question, first part. This part, remember, we can use a calculator. You know? So this part again, we're doing this, we want to ensure that we work out the entire numerator first. You have to get the value of the numerator first if you were to go step by step. If you can type it as it is in the calculator, then you basically will get the correct answer just the same. So if we were to go step by step, the 3.1 minus the 1.15 will be equal to 1.95 square, and you square that. This is a square on the outside there. Still divided by 0.005. And then that now, when you work out the 1.95 square, to put the exact value, it will become 3.8025 divided by 0.005. And then you use a calculator, you work that out, you will get a value of 760.5. Basically, that is it. Right, you can check it with me as you go along. Check it with the calculators as you go along. Right, so that's what you're supposed to get. All right, that's the first part. Right. So moving on now to the next question on the next page. All right, so this is it. So this is a consumer arithmetic question. Some consumer arithmetic stuff. All right, so I'll leave it here so we can always be looking at it. So this question says, a store is promoting a new mobile phone under two plans, plan A and plan B. So the plans are advertised as shown in the table. So this is plan A, and this one is plan B, two plans. So there are two plans under which you can buy the phone. Under plan A, you make a deposit of $400, then you pay monthly $65, and you do that for 12 months, and then you don't pay any tax. There's no tax that you pay. All right, so that's how you get the plan A phone. Under plan B, you make a deposit of $600, and you pay $80 monthly for 6 months. But then now you have to make a 5% payment on all payments. 5% tax is charged on all payments. So they're charging a 5% tax. It means that the new total on any total after you add the 5% tax is going to be 105% of that total, because you're adding 5% to what you're paying. So therefore you're going to be paying 100. You're going to calculate the total cost, and then to add the tax and get the overall total that you're paying, including the tax, you would have to multiply by 100. You'd have to use 105%. It is 5% more than the total. So that is simply 105%. So I want to establish that up front. All right, and be mindful of that. So the question says we have to calculate the cost of the phone under plan A. So it's quite simple. The plan A cost, let's call it cost A, would be equal to, cost A would be equal to the deposit of $400 plus we're making 12 payments of $65 each. So it's 12 times $65. Right? And you work that out with the calculator, and that will come to 1,180. So that is the plan A cost, the cost under plan A. All right, so that's the first part. The second part says we are to determine which of the two plans, A or B, is a better deal. So the better deal is the one that you basically get in a phone for less overall. All right, so to determine which one is a better deal, we now have to go and work out what the cost would be. Okay, if you look over here, we have to go and look what the cost would be under plan B. What will be the cost under plan B? We worked out plan A already. So the plan A cost is 1. It's a smaller ink. All right. So the plan A cost. Where is this? Sometimes this thing gives me some problems. It's here already. But the plan A cost. Plan A cost. Let's erase all of this. Can I erase again? All right. The plan A cost is 1180. That's the plan A cost. So to make the comparison which one is better, we need to now work out the plan B cost. Right? So let's work out the plan B cost down here. So let's call it cost B. Plan B cost, we're going to call it cost B. Now remember, you have to add 5% to the overall total now. All right, to get the total cost that they pay. All right, so the plan B cost, we're going to call it cost B. Cost B would be equal to the total that you're paying would be $600 deposit. And then you're going to do 6 payments of $80 each. So that will be 6 times $80. All right, but remember now you have to also add tax. So the tax you add in is 5%. So therefore, the overall cost after you add 5% is that you have to multiply that result by 105%. 105% is basically 105 divided by 100 by 100. Right? So if you do the calculation, right, it would be, what would the cost be before you add the tax? It would be 600 plus 6 times 80, which would be 1080. That would be the cost. But then you know have to add a 5% tax. So to add a 5% tax, you can multiply this by 105 over 100. Right? That is the 5% tax that you're adding right there. So you multiply by 105. That will be the new value after you add the tax. So you don't want the total, so you don't need to actually record the tax. If you wanted, you could record 5% of this 1080 and then add that result to the 1080, right? But we don't need to do that. So all we need to do now is multiply this by the 105%. And 105% is simply 1.05. All right, and so that total is 1134. And so over here we can write that the plan B cost is 1134. So clearly this one is cheaper, and so this one will be the better buy. The better buy, because it is cheaper. So plan B will be the better buy because it is cheaper. So we can write it down here as well. This one is the better buy. Better buy because it is cheaper. All right, that's it. It's cheaper if you get the phone for less. If you use that plan. All right, remember, if you have any questions, you can ask me right away. I'm just see if there's anybody in waiting. All right, now. All right, so let's continue. Just started thinking of some problem. I don't know why today. All right, let's move to the next page. All right, so the next part now, part C, gives us another consumer arithmetic question. Right, let's move down on this, which is right here. So we can look at two of them simultaneously if needs be. All right, so this one says, hold on a second. I'm getting my glasses. All right, so this one says, John's monthly electricity bill is based on the number of kilowatt hours, kWh means kilowatt hours, of electricity that he consumes for that month. All right, and they say he's charged $5.10 per kilowatt hour. So this is the charge per kilowatt hour. So all you have to do is multiply the number of kilowatt hours that he uses by 510 cents, and that would be his electricity charge. That's what basically this is saying per month. It says for the month of March 2016, the 2-meter readings are displayed in the table below. So this is the meter reading at the beginning of the month, and after he used up his electricity, this is a meter reading at the end of the month. And so the difference between these two figures is the amount of kilowatt hours that you would have consumed. All right, so and then once you find that amount consumed, you basically multiply that amount consumed by the rate. All right, so the first part says we have to calculate the total amount of that John pays for electricity consumed in the month of March 2016. So the amount that he pays is the amount consumed times the rate. All right, so let's write it like this. So the amount that he pays, so he pays the payment, let's say it's a payment, the charge, let's use a blue ink as well. All right, so the charge will be equal to the amount consumed, like kilowatt hours consumed multiplied by the rate of $5.10. Simple calculation as that. And the amount consumed is the difference in the meter reading, right? Which essentially you don't need to include the zeros when you're doing the difference, right? It's just this value minus this value. You don't even have to include the 3. You can just do the 307 minus 11. All right, but in any case, if you write the 3307 minus the 3011, that is the amount consumed. The difference in those two meter readings multiplied by $5.10. Right, and that would work out. That would work out. If you calculate that now, it will come out to be. Let's calculate the difference and show what the difference is. So it's 3. The amount consumed will be 296 kilowatt hours times $5.10 is the charge per kilowatt hour. So that would basically be a total charge of 1509. It gave me 0.6 on the calculator because it's money you're talking about. You have to put 60 cents. So basically that is it. That's the amount that you would have to pay. All right. So the next part now says, for the month of April, he pays this amount for the month of April. That's the total amount that he pays for the month of April. All right, for electricity consumption. Determine his meter reading at the end of April. All right, so remember now, over here, look over here. We're now going from March to April. So the meter reading is going to change. All right, so what you want to do is know how much it changed by looking at the cost. So you want to know how much kilowatt hours he used, and then all you need to do now is add that kilowatt hour to this meter reading, and then you will know the new reading. As simple as that. If you don't understand, let me know. All right. So we want to work out the kilowatt hours used. All right. So the kilowatt hours used are consumed in April will be equal to total that he paid, which is 2351.10 divided by, I might leave out something, 2351. It's correct. 2351.10 divided by the rate. Remember now that the rate over here is $5.10. So it pays at $5.10 per kilowatt hour. So the total divided by $5.10, I'm going to tell you the total amount of kilowatt hours that he used, a total number. So it's 2351.1 divided by 5.1, $5.10. And that is giving me 461. 461. That's the kilowatt hours that he used. And so the new meter reading at the end of April meter reading. All right, let's write it. End April reading is basically going to be the end of March reading, which was 03307, plus the amount that he consumed, because the meter is going to increase by 461. And remember, it's a meter reading, so I have to put the same 0 in front. It have to write by the meter reading as it was. So it's 3307 plus the 461. And so the new meter reading is 03768. You have to write by the 0 in front there, because that's how the meter reading is presented. And person asks for the meter reading, so you have to put the 0 in front. Okay, you want to show what the meter reading would be. All right, and basically that is question number 1 completed. Remember, if you don't understand something, let me know. All right, so let's move to the next question. Question 2. All right, so question 2 now is your algebra question. All right, question 2. So part A. Let's look at it over here. Part A is to factorize this thing. So basically it's a factorization question in part A. We have 3 parts in the part A to factorize. So here now, as the 2 terms with a minus sign, so I'm thinking the difference of 2 squared, but first I have to look for a common factor because these are not perfect squares. 18 is not a perfect square, 6 is not a perfect square, so this is not the difference of 2 squares. So all we can do is look for the highest common factor. So look for the highest common factors in the numbers, 6 and the 18. The highest common factor is 6. Highest common factor in the y values between this and this is a y. And in the x values, this has no x value in it, so x is not a common factor. So basically that's a common factor. And then it's like you're dividing the 6x out of the 6y out of this term and out of this term. All right. So if I divide the 6y out of this term, I'm left with a y right here. And then I divide the 6 out of the negative 18, I'm left with negative 3. And then there's no x dividing out, so the x comes back. And I divide out the y already out here, and basically that is the result. All right, so that is the result right there, step by step. And what you can do sometimes is just expand this back and see if you get this. Just do a quick expansion of this side and see if you get what you factorize. All right, so it's a good practice to do. But that is the correct answer. All right, down here now, second question down here is the difference of 2 perfect squares now. And now you have to know the type of factorization that you can get in the exam. You know the type that you can get, when you see it, you'll know. You have to also remember that 1 is a perfect square, and that's what got a lot of persons in this question. They don't realize that 1 is a perfect square. So this can be written as a difference of 2 squares. 4 is a perfect square, and the m squared is a perfect square. So it can be written as the difference of 2 squares like this. It can be written as 2m all squared, and the 1 is the same as 1 squared. And then we apply the rule for the difference of 2 squares. Now it becomes 2m minus 1 times 2m plus 1. If we apply the rule for the difference of 2 squares, and that is it, factorize. All right, we'll come down now to this question, which is a quadratic. Remember, we're doing a quadratics now. It's a procedural operation to factorize it, but through a procedure. And the procedure is to break out the 3 terms and the 4 terms, right? And you do that by splitting the middle term. You split the middle term into 2 terms. So you have 4 terms, and you can factorize by parts. But if you split the middle term in a particular way, so you can have a common factor when you factorize the first 2 terms and the second 2 terms. And the way to do that, let me do it over here in red. We're going to split the middle term. Is that you multiply the 2 on n coefficients first, and you have to note the negative 2 is the n coefficient, the c. All right, so you multiply the a and the c. So it becomes, you multiply 2 times minus 2, that equals minus 4. And you're basically looking for factors of minus 4 that add to the middle term of minus 3. That's what you want. Factors of minus 4 that add to minus 3. And you're going to search for the factors down here. All right. Now, since you want factors of a negative number, negative 4, then one of those factors will be positive and one will be negative. What you do, you give the larger of those 2 factors a sign of this thing up here, which is negative. So the larger of the 2 factors of negative 4, you're going to make it negative. So the first 2 factors are 1 and negative 4. Are the first 2 factors. Let's put it this way first. It's 1 and 4 are the factors of 4. And then you give the larger one the negative sign and the smaller one the positive sign. And then you add them. The negative 4 and the 1 gives a negative 3. So yes, you already found what you can split the negative 3t here. You're going to split the negative 3t into plus t, plus 1t, and minus 4t. All right, so that's what this information tells us. So let's go back to the blue. So we're going to split this now. So when we split this, we're going to get 2t squared plus, we can put t out, we can put plus 1t minus 4t minus 2. That's what you get. And you always check when you split the middle term here to ensure that you will get back the same thing in the middle right there. So the 1t minus the 4t would give you back the minus 3t, so you know that everything all right. And you do the highest common factor in the first two terms. And that would be basically t. So it will be t into 2t plus 1. And the same thing to do is that you must have the same thing in the bracket over here. So I always advise the students, write by the same thing in the bracket first. 2t plus 1. When you write back the first, write that back in the bracket, you want to decide what factor coming out here now. So it's either plus something or minus something must come out here. And it is a factor that you would need to factorize this negative 4t down to positive 2, for positive 2t, right? And that will be a negative 2. Because if you had negative 4t and you factorize down to get a 2t inside there, it means that you would have factored out a negative 2. So you factor out a negative 2. You always have to put plus something or minus something out there, remember. All right? But that's going to dictate what goes in your bracket and you factorize the next line. And what you normally do right, is just double check the factorization. So it's negative 2 times 2t gives you the minus 4t, which is good. And then negative 2t times 1 gives a negative 2, which is also good. So I always make that little check to make sure that everything okay. And then the highest, the 2t plus 1 is now a common factor. And so it's t minus 2 times that common factor. So it becomes t minus 2 times that common factor of 2t plus 1. Those are your factors. Now if you did it, if you had done it and put the minus 4t in front of the 1t, right? What could possibly happen is that you could get the same two factors. So you can say, or get the same two factors, but you put the 2t plus 1 in front. But it doesn't matter. It is still correct. It's still the same two factors. So to get it that way, no problem. It's still correct. All right. So that is it so far. Let's move down now to this part. All right, which is basically now this. I want us to write that as a single fraction. Remember, when you're adding fractions or subtracting fractions, you want them to be related. You want two denominators to be the same. All right, so what we can do to make the two denominators the same is multiply this denominator up here and down here, and the denominator over here become 12. And we can also multiply this denominator up here and down there, and this denominator also become 12. All right, so how you show that in the workings is that you write this one, multiply this one by 4 over 4, and multiply this one by 3 over 3. All right, it here, 3 over 3. All right, and you're careful with the signs. You be careful with the signs, especially the negative sign. All right, pay attention. So let's work out and see what we get now. So the 4 times 5p is 20p. The 4 times 2 is 8. Divided by the 4 times 3 is 12. Minus. And this now you're multiplying the 3 by those now, right? And so 3 times 3p is 9p. And 3 times minus 1 is still minus 1. All over 4 times 3 is 12. So now the two denominators are the same. All right, and because the two denominators are the same, you can just write it now as 20p plus 8. Now remember, this minus is subtracting the entire numerator. That's where people make the mistake. All right, you're subtracting the entire numerator. So you're going to get minus 9p first. That's minus 9p first. That's what you're going to get. So you get minus 9p. And then you get minus a negative 3. So minus a negative 3 give you a positive 3. Right? And then you divide that now by the common denominator of 12. And then all you have to do now is work out this thing, work out the like terms here. So 20p minus 9p is 11p. That's this one minus this one. Right? And then the 8 and 3 is 11. 8 and the 3 is 11. So I get plus 11 and dividing that by 12. So that is my answer. Right there. Alright, that is my answer. And I'm just simplified. So if you wanted, you could have also written this as 11 into p plus 1. Factorize out 11 over 12. Could have written it like that if you wanted. And put a mark between them. So if you wanted, you could have written it like this instead. Alright, but I think if you leave the 11p plus 11 over 12, you get the marks as the same. If you factorize the 11 and put it as 11 bracket p plus 1 over 12, they give you the marks as the same. Alright, and basically that's that. Alright, the next part now. To see if everybody coming on okay. I still have people in waiting. Let's see. Let's check that fast. Alright, like everybody coming on nicely. Alright, good. So back to this. Right. So at this question now. Let's look at it over here. Alright. Good. So this question says a formula is given as d equals the square root of 4h over 5. Alright, d equals the square root of 4h over 5. It says determine the value of d when the h is 29 and give the answer to 3 significant figures. Give the answer to 3 significant figures. So when let's see another color. Oh, I used the blue. So when h equals 29, the d will be equal to the square root of 4 times 29 all over 5. Alright? And you can work out what is under the square root sign there, and you'll come to the square root of 23.2. 23.2. And so when you work that out, the d becomes, let's work it out, 4 times 29 divided by 5, we have 23.2, and you square root that. When we square root it first, for you correct the 3 significant figures, you're gonna get 4.816637832. That's what I'm getting on my calculator. But the question is must correct the 3 significant figures. Alright, so the first three significant figures are this one, and this one. Now this is the third one, so we need to correct this one, this third one. You correct this third one with this value. This value is 6. So since that value is a 6, right? Remember, once it is 5 or more, you're gonna increase now the one that you're correcting by 1. Alright, and so the final figure corrected 3 significant figures would be 4.82. 4.82 to 3 significant figures. To 3 significant figures. And basically that will be it. Alright? That will be the answer. If you corrected it to 3 significant figures. The next part now says you must make h the subject. Now remember, I know this is what we're trying to know. Make h the subject of this thing. Alright? I want to make h the subject now of that. Alright, so what we're gonna do to make h the subject, we're gonna rewrite and put the h on the left side. If we want to make h subject, we want to leave h on the left side. So we're gonna rewrite the equation as this: square root of 4h over 5. Let me write that better. That don't look so good. Right, so let's go again. Square root of 4h over 5 equals d. So essentially you want to move everything away from the h and leave the h as a subject, right? And you have to follow the correct sequence. So the first thing you want to move is the square root sign. And the inverse of square root is square. Alright? So if you square both sides, then the square root sign will be gone. You'll eliminate the square root. All right. So when we square both sides, we're going to get 4h over 5 equals d squared. And then to leave h as a subject, it's quite easy. We cross multiply. So multiply up the 5 and divide down the 4. So it's like we multiply both sides by 5 and divide both sides by 4. So it's quite easy, right? Let's go step by step. The 4h becomes 5 times d squared. Like I multiply both sides by 5. And then they need to divide both sides by 4. So the h now becomes 5d squared over 4. And that is it. You have made h a subject. And that is h as a subject right there. All right, nice and easy. All right, so let's move now to the next question. There's no question 3. All right, so question 3 now is a set question.
Guess the money show me time and that PhD
Hold on,
2031.
hold on, there's somebody talking.
Of course, I'm so caught.
All right, just help them out there. All right, so question 3 now is a set question. It says the universal set is defined as U equals X is such that X is a member of natural numbers. This N means natural numbers. Remember, your natural numbers are your counting numbers. And people count from 1. That the numbers that you start counting from as a baby, numbers that you count naturally. Natural numbers. So it's 1, 2, 3, 4, 5, 6. Then if you include 0, it will be the set W, set of whole numbers. So 0, 1, 2, 3, 4, 5 will be your whole numbers. The natural numbers start from 1, and they are the whole numbers starting from 1 are your natural numbers. Right? So this comprises of natural numbers. And it is such that the x is greater than 2. This means that the 2 is not included. And at the same time, the x is less than 12, meaning that the 12 is not included. So essentially it's from 3 to 11. Right? So if we were to list the universal set, you can basically list it like this. You can list it as 3, 4, 5, 6, 7, 8, 9, 10, and 11. Right? That basically becomes the set. If we were to list the values in that set, based on that description. Right? The whole numbers between 2 and 12, basically. Natural numbers between 2 and 12. Between 2 and 12. Those numbers start from 3 and end at 11. The next part now says, it tells us now that M and R are subsets of U, where M are the odd numbers. So we know odd numbers are numbers that are not evenly divisible by 2. And then R are the squared numbers. So squared numbers basically your perfect square numbers. Squared numbers you can square root them and get a whole number, right? Perfect squared numbers like 4, like 4, 9, 16, 25. Those are your squared numbers. All right. So here they want us to list the members of M, which are your odd numbers. So M would be the set of odd numbers. So it will be 3, 5, 7, 9, 11. Remember, that must be in the universal set because the M is a subset of the universal set. And then R now are your squared numbers. So R, if we were to list them, they want us to list the set R, the squared numbers. Numbers which are perfect squared. All right. So the first one is 4. And the other one is just 9. So 4 and 9 are the only 2 squared numbers because like 2 squared and 3 squared. All right, so those are squared numbers that can be written as perfect squares. All right, simple as that. And then down here now, they want us to draw a Venn diagram to represent that information. All right, so draw a Venn diagram to represent the relationship among the defined sets in U. All right, so remember the Venn diagram You always start the Venn diagram as a rectangle. Rectangle. And you put the U as universal set out here. Some people put it up here, don't matter. All right. And then now you're gonna draw the two subsets where you check if they intersect, if there's an intersection, if there's any value that is common to both of them. Okay, mark it. See it here, the 9 is common to both of them, and so it means that there's an intersection of the two of them. So it makes sense to draw them with an intersection, right? So let's draw the M and then put an intersection and draw the R. So this is M and this is R. And the way now I'm going to do is fill out the intersecting value first. Let's put in those values in red. Let's fill them out in red. So put in the intersection value first. All right, so the intersection value is a 9, so put that in first. And then now you can complete this one, complete the R, put all the other values, which with this, the other value is just 4 in R, so you put a 4 there. And then the other values in M would be the 3, the 5, the 7, and the 11, those 4 values. 5, 3, 5, 7, 11. All right. And then we have to ensure that all the values in the universal set are accounted for. So all numbers that are not in these two now have to be included. So what you basically do is just go through and check. And any value that is not already listed, you write them down out here. All right, outside those two. So let's go. 3 is there, 4 is there, 5 is there, 6 is not there, so put 6 out here. 6. 7 is there, 8 is not there, so we can write 8 right there. 8. 9 is there, 10 is not there, so I'm going to put 10 out here. And then 11 is there. What you can do is count to make sure you have all of them. So the set has how many numbers in the set, how many values in the set, how many members? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 members. And you just check, make sure you have 9 values here. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it basically indicates to me that I've accounted for all of them. And so that's my completed Venn diagram. All right, so basically that is it for that question. All right, that's it for that question. Let's move down to the next part. It's on a page by itself. Yeah. All right, so this is a construction. Kind of difficult to do the construction. Yeah, well, let me see if I can just explain it. It's kind of difficult to do it here without instruments. I can't use instruments on this thing. All right, so the question says you have to construct accurately a square. All right, and each side is 6 centimeters. Right, construct a square where each side is 6 centimeters. So, each side is 6 centimeters, a square. So that's what I'd usually tell students is make a sketch of what you're gonna construct first. But a square, you don't have to sketch a square, because we know what a square is, right? So first thing you're gonna do is use a ruler. Use a ruler and draw a 6 centimeters line. All right, so let's say that's my 6 centimeters line. Use a ruler and draw a 6 centimeters line. All right, so use a ruler and you draw a 6 centimeters line. All right, so let's say you draw your line, and your line is that. That's the 6 centimeters line. All right, and let's say we're gonna make here be A, this end, and this end be B. All right, A and B. Then if it's a square I'm drawing, I need to have 90-degree angle here and a 90-degree angle here. So the question is, how do we construct a 90-degree angle? There's more than one way to do it. All right, but I'm going to use a simple way where we bisect a 180 degrees. So since we want a a 90-degree angle, what I can do is basically extend this line and extend this line. All right. So basically that's something like that. Extend the lines. All right. And then now, what it is that you want to bisect the angle right here, this mark. So you open your compass to about this region, open your compass to about that region, right? And from this point, put the point of a compass on that point, put the point of a compass there, and then you make an arc with the pencil. Make an arc with the pencil that goes across there, something like that. All right. That's what you do. And then what it is now is that you're bisecting the line segment between these 2 points. All right, you're bisecting that line segment between those 2 points. What you're going to do now, you're going to put the point of the compass over here. Right? Put the point of the compass over here. And then you open the compass, make sure that it's more than half. So you open the compass maybe to about here, this length. All right, you're bisecting a line segment now. All right, and then from here now, you make an arc of the top. From this point, you make an arc of the top. It's gonna go like this. And then from this point, and don't change the angle of the compass, you know, make the compass stay as it is. You make an arc across this one. It's gonna go like that. All right, something like that. From that point. All right, so that's what you do over there. And you do a similar thing. You do a similar thing on this end. On this end. So same thing over here. Make an arc over there. So we use a different color for this construction. We use a different color for the construction. Let me do it over with a different color. Let's use a different color for the construction. Let's use a red. All right, so ready again. I'm going to make an arc first from this point. I'm going to make an arc. So make an arc over here. And it's like a bisecting this line segment. So you put a point here, open the compass to more than half, and make an arc at the top. So from now, this point, I'm making an arc at the top. So make an arc up there, like that. And then from this point, you make an arc across this one, across that one. And you do the same thing over this end. From this point, you make an arc, arc because you're bisecting a line segment. From that point, you put a point there, open the compass, and you make an arc looking something like that. Right? And so now you're bisecting the line segment between here and here. And what you do now, you put the point at this one, you make an arc at the top. Same thing that we did over there. Make an arc at the top. And then from this point, we make an arc here, across there. All right? And then all you have to do now is use your ruler and draw a straight line through the point and the intersection, and use your ruler and measure it 6 centimeters. So you draw a straight line through the intersection here, and you measure at 6 centimeters, and you do the same thing, draw the straight line through the intersection here. And use your ruler now and measure at 6 centimeters. All right, so you measure at 6 centimeters. You mark it off. So I need to extend it. So I'm putting this as my 6 centimeters and extend this one as well. Mark this as a 6 centimeters. Measure it with the ruler. For the question say you can use a ruler. And then you just join these 2 points across here now. That's it, you have a square. Alright. That's the first part. And you label it up now. A, B, C, D. A, B, C, D. All right. And the next part now says, construct an extension. Let's read it over here. It says construct an extension of your diagram. So must construct an extension of this diagram up here now. Construct an extension of your diagram in B1. Right? We need a trapezium to construct it to a trapezium. Construct as an extension to your diagram in B1 the trapezium DABQ. All right, now the DABQ kind of important, you know. DABQ must be in the same direction around the object in terms of where the values are, where the points are. So since we have D up here, A down here, and D down here, DABQ must go around like this. So Q must be somewhere up here. DABQ. Q must be somewhere up there. Remember the trapezium we're doing, you know. So it must have two pairs of parallel sides. And it says, what did it say? It says that the angle ABQ, must be 120 degrees. So we said Q somewhere up here. And they're telling us now that the angle ABQ inside here so must be 120 degrees. That's what they're telling us. So let's reason it out. That angle must be 120 degrees. So let's reason it out. We write a schematic. All right, let's reason it out. So I'm going to erase this and we'll just reason it out before construct. I'm reason it out, you know what the construction. So what? Let's look at it now. Do like a sketch. We have the square. A, B, C, D. And then we have to construct now AB, an angle ABQ must be 120 degrees. This angle must be 120. Let's use a red and show it. Let's use a red and show the angle. All right, what we need to do. So we can figure out what we need to do. So this angle is 120 degrees. Remember that in here so is 90, you know. So that one be 120 means that this angle here so now must be 30 degrees. If that angle is 30 degrees, then really and truly to this line, this angle is 60 degrees. And so it boils down that to construct this line, all we really need to do now is construct a 60-degree angle on this line, and we would have this line. And then because a trapezium, when we extend this line to get the trapezium, we need to extend this line to meet it out here. So D will be somewhere there, and that will be the trapezium. So we need to construct a 60-degree angle out here, so basically. So let's go back on the diagram and show it now. Let's go back on the diagram. So we're going to construct a 60-degree angle out here. All right. We'll construct a 60-degree angle. We're constructing a 60-degree angle from this line now. Let's extend this line again. Constructing a 60-degree angle on this line here. All right. So how do you construct a 60-degree angle? Let me use a different color for that construction so we can see. Let me use a purple. We'll construct a 60-degree angle from that point. So basically, put a point here on the compass and you make an arc. Let's make it a little wider so we can make them different. Make an arc. The arc will go like that from that point. Make an arc up here. Then what you do, you move the point of the compass to this point. Don't change the angle of the compass, just move the point of the compass to this point, and then you make an arc across this one, like this. And so you put a point here first, make this first arc, then you move the point to here, mark this second arc here. All right, and then now go back for the blue. When you use a ruler now, and you draw a straight line through here. You draw a straight line through there, right? this angle is going to be 60 degrees inside here. So this angle here is going to be 30 degrees inside here. And so the whole angle that they wanted, let's use a different color for that. Let's use a green. The angle from here to here now is going to be 120 that they wanted. 120 degrees that they want. But to be 90 plus 30. And then all you have to do now, use your ruler and extend this line up here now, the DC line. Extend it. Use the go back for the blue. And extend this line now. As I said, as an extension. So extend this line like that. And then this point becomes Q. There you go. Alright, what you need to do is get your geometry set and try and do this construction by yourself. Alright, try and construct it for yourself. Alright. Basically, that's it. That's that question. You put a point here. Alright, so basically that's it. Alright. Let's move to the next one. Oh, so hence measure and state the length of BQ. Measure and state. So you basically use a ruler to measure the length of this line BQ. That's what you'll have to do. Use a ruler and measure it. You can actually calculate it, you know. Since you know that, let me show you how you can calculate it quick. You don't want to calculate it, but you can calculate, just make sure you have the right answer. Now remember, if you look at the triangle here, that we have, this is B, this is C, and this is Q. That is this triangle here that I'm drawing. Right? Remember that this angle is 30 degrees. And this side is 6 centimeters. So we can use cos equal adjacent to hypotenuse and calculate it and make sure it's right. And if I'm in an exam, I'm going to calculate it and check. Right? So I would say to calculate this length BQ, I would say cos 30 degrees equals adjacent of 6 over BQ. And I'll multiply BQ and divide on the cos of 30. And so the BQ, I'm not showing this on the work, and I'm just checking it for myself and not submitting this because the question said measure. So you can go and show no calculation for it, just measure. And there's 1 mark for it. I'm just calculating it to make sure that my answer is correct. So the BQ would be 6 divided by the cos of 30 degrees. And whatever I get for that, I'm writing it to 2 decimal places as my answer. So it will be 6 divided by cos of 30. And it will be 6.93 or something like so. So I would write down here now as my answer. So I wouldn't show this work. This work here, I would not show none of this work on the paper. I'm just doing this part rough for myself to see what the correct answer is, and then I'm measuring it as well. And once your calculation and your measurement good, you know that the construction good. So that when you do it, you're supposed to get BQ equals 6.92 centimeters. That's going to be the length of it, 6.92 or 6.93, I should say. If you correct it, if you get 6.92, no difference. So do it, construct it, and check it for yourself and see what you get. All right, students, that's what you need to do. All right, let's move on. Next question, question 4. All right, so question 4 says, this is a functions question. F of x is straight over here, and they want us to first calculate f of 3 plus f of negative 3. So f of 3 is just putting 3 in the f function, right? So it's f of 3, let's write it, f of 3 plus f of negative 3 would be equal to, the f of 3 becomes 1/3 of 3 minus 2. That's f of 3 plus f of negative 3 now would be 1/3 of negative 3 minus 2. All right, so basically this is going to eliminate this, you know, because it's going to give me 1 and it's going to give me -1, so they eliminate each other. those two. And so my final answer is -2 and -2, which is -4. So the answer there will be -4. All right. The next part now says, calculate the value of x for which f of x is equal to 5. So to solve f of x equals 5, we can just write what we're really trying to solve is that 1/3 x minus 2 is equal to 5. That's f of x equals 5 we're solving. All right. So we're solving this for the x. It's a basically transpose and make x a subject. All right. So we can cover the 2 first and get 1/3 x equals 7. I add 2. And then to get rid of the 3, I multiply by the 3. And so you get x equals 3 times 7. X equals 21. And so x equals 21 there. All right. Next part down here now wants us to find f to the minus 1 of x. F to the minus 1, which is the inverse. All right. So using this same function that we have over here, the f of x function, you can start and leave out the of x and just say f equals 1/3 x minus 2. And then we'll form the inverse function. Forming the inverse function. You interchange the domain and the range. Now, f represents the range, it becomes the domain in the inverse function. And the x up here represents the domain of the function, it becomes the range in the inverse function. Range in the inverse function is written with the f to the minus 1 minus 2. And we basically know transposing to make f to the minus 1 a subject. So the first thing I'm going to do is square what is -2 over here and add it. So I'm going to get x plus 2 equals 1/3 f to the minus 1. And then to get rid of this 3, I multiply this 3 across here. I can say multiply both sides by 3. All right, so we're going to get basically 3x plus 6. That's a 3 times x and a 3 times 2. Give me 3x plus 6. Right? And that now leaves with f to the minus 1. So I can write the final thing. F to the minus 1 equals 3x plus 6. And I can put in back of x now that we're done. So it's f to the minus 1 of x that I wanted. Alright, and basically that's it. Alright, 3x plus 6. Alright. Next part, which is on the next page. Let's undo this over here. And move up to the next page. Alright, so give us these 2 lines now on the next page. Right, so this question now gives us this graph. And it says, the graph below shows 2 straight lines, L1 and L2. Right, so this one is L1 and this one is L2. Those 2 lines, L1 and L2. Right, now clearly L1 is a positive gradient because as you go from left to right on L1, you're going upwards. So that's a positive gradient. And L2 is a negative gradient because as you go from left to right on L2, you're going down. That's a negative gradient. Alright, so L1 is a positive gradient because it's going up. L2 is a negative gradient because it's sloping down. It's slope, gradient is slope. It says L1 intersects the y-axis at 0, 1, which is right here. You can see it. And line L2 intersects the x and y-axis at 12, 0 and 0, 6. It's 12, 0 and 0, 6. All right, those are the intersecting points. All right, and the first part now is telling us, we can use the diagram over here and work from this diagram. It's telling us now to calculate the gradient. Calculate the gradient. Now, gradient can be calculated easily. We don't have to actually calculate this. It's going to give us a graph. Right? We can just observe and do it from the graph. Now, gradient is rise over run from one point to another point on the graph. Since you have the graph from between any 2 points on the graph, so we can just use 2 convenient points on the line. So for L1, we can use this point and this point, and just count the rise and count the run. Right? So from that point to that point, you rise 2 up to here, and then you run 1 across there. So this is a +2 rise, and it's a +1 run. Right? Rise 2, run 1. Let's use a smaller marker. Right? So this is a +2 rise and a +1 run. But the rise is going up like that, and the run is going to the right, like that. All right, so simple. All right, first one. Gradient of line 1 equal rise over run between any 2 points on the graph. Rise over run between any 2 points. Between those 2 points, the rise is 2 and the run is 1. So the gradient of that line is 2. So that's that. For line 2, there's a similar calculation. You can use any 2 points on this line. Let's use again. So let's say we're using this point to this point. Any 2 points that you know the values, you can use. So this one, the rise, you go down. So the rise is negative, you go down, and then you run 2 to the right. Right? So this one is a -1 rise, because you go down, as a +2 run, you go to the right. So rise -1, run 2, +2. So again, you come back down here and use the rise over run formula for line 2. Again, it's rise over run between 2 points on the line. Rise over run. We're doing it the easy way. You could have calculated it using the coordinates at the tables, but we don't need to do that. All right, so it becomes rise -1 over run 2, +2. It's -1/2. It's gradient of that second line. The 2 lines. Simple. 3 marks. Right? 3 marks. All right, moving on to the next part. The next part now says we have to determine the equation of line 1. Now, for line 1, we know so line 1 cut the y-axis at thing there now. Let's look at this diagram. Line 1 pass through the y-axis there. Right, so for line 1, the gradient of line 1, we work it out and it was 2. And the c on line 1, you see it on the graph, it is 1. The equation is simply y equals mx plus c. Since it's line 1, we're using line 1 gradient and the line 1 y-axis intercept. And so you don't need no calculation. Just y equals 2x plus 1. Done. Y equals 2x plus 1. Alright, if we were doing line 2, that is line 1. This is for line 1. Line 1. If the question had asked us for line 2, which it didn't, right? If that asked us for line 2, for example, line 2 is a similar consideration. The gradient of line 2 is -1/2, and the c for line 2 is right here. C for line 2 is 6, so it's here on the graph. C for line 2 is 6. And the equation is still y equals mx plus c. When you know the gradient and the y-axis intercept, you don't need a calculation, that's right, the values. Talking about line 2, so the gradient of line 2 and the c for line 2. And so it will be y equals -1/2 x plus 6 if they wanted line 2, but they didn't want line 2. But because that's what they wanted line 1, they could have wanted line 2 instead. But that's what you'd have to do. Next part now says what's the relationship between the 2 lines and give a reason. Right? Now, what you can use to know the relationship between the 2 lines is the gradient, the slope. Alright, and if you look at the diagram, you can see that they are perpendicular, they look perpendicular. Right? They look perpendicular on that graph. But the gradient can tell you if they're perpendicular. Right? If the product of the gradients is -1, then they are perpendicular, which that is the case. Right? Because the m1 times m2 works out to be 2 times -1/2. 2 times -1/2. M1 is 2 and M2 is -1/2. So that gives you -1. That works out to -1. Alright. And you're in the product of the gradients. Alright. negative 1. When the product of the gradients, so therefore, m1 times m2 is negative 1. When the product of the gradients is negative 1, means that they are perpendicular. Therefore, L1 is perpendicular. You can write out the word perpendicular, but this means perpendicular. Is perpendicular to perpendicular to L2. Two lines are perpendicular. That's the relationship between them because the product of the gradient is negative 1. When two lines are parallel, the gradients are the same. Right? So they were parallel lines. They would run parallel to each other like that, and they would have the same gradient. But in this case, we have perpendicular lines. All right, so basically that's that. Okay, so let's move on to the next question. With this one, question 5. All right, question 5 gives us this diagram right here. All right. I need to mark on this side, so let's make an adjustment. All right, cool. All right, so this question says PTRS not drawn to scale, means that you cannot put any protractor and a ruler on it. It's not drawn to scale. All right, you cannot go by how anything looks. All right, you have to go by your calculation. It's a quadrilateral. It says Q is a point on PT such that QT equals QR equals QP, and that is shown by these marks. So these marks mean that those sides are equal. So I don't need to read this information again. Information is indicated on the diagram by those marks. If they were not there, I would put them there. But since they are there, it's fine. Those marks mean that the lines are equal in length, those three lines. And since those lines are equal in length, it means that this is an isosceles triangle. These two base angles equal, this angle and this angle equal. And also, this is an isosceles triangle. These two angles equal, this angle and this angle down here equal. Right? They're isosceles triangles. Triangles with two sides equal are isosceles triangles. All right, so you know that we're working with some isosceles triangles there. And if you know one angle in an isosceles triangle, you are blessed because you can find other two easily. All right. It says determine given reasons for your steps in your answer. The measure of first angle RQT. Let's see what angle RQT. Angle RQT is this angle right there. Angle RQT. So, because that's an isosceles triangle, we know that this angle down here is also 76. This angle down here is also 76. And when the angle is 76, then this angle that we want is going to be 180 minus 2 times 76. 180 minus 2 times 76. And so I can write that out for me. I have to write it out myself. That becomes 28 degrees. So it's 28 degrees. All right, so let's write it on the diagram. As you calculate something, you put it on the diagram, but we have to show the reasoning down here. So down here, we're gonna say, to calculate this, we're gonna say first the angle RTQ equals 76. Let's put angle equal to first equals angle QRT, which is 76 degrees. And that's because we have an isosceles triangle. The reason is an isosceles triangle RQT. Then the triangle RQT is isosceles. That's why them equal. And therefore, the angle that we want, angle RQT equals 180 degrees minus 2 times 76 degrees, which is 28 degrees. And the reason for that is that total angle in triangle RQT is 180 degrees. That's the reason. So them must give the reason. So sheet here is a give reasons. So you're gonna give reasons with calculation. I'll give reasons in writing in words. All right, so let's put in what we know on the diagram. The more info, as you find information, you put them on the diagram. That will help you to find what else you need. So this is 28 degrees right here. 28 degrees. Next part now wants us to find angle PRT. Angle PRT. Now angle PRT is all of this angle across here. All of that angle is PRT. So since we know that piece of it already is 76, then we really need to find this piece here now. Add to 76. All right, need to find that piece there. Now that piece can be found number of ways, but because that's an isosceles triangle, this angle P that I want is equal to this angle down here that I want. And there's a rule that says the external angle of a triangle is equal to the sum of the two opposite interior angles. Now, what does that mean? Let me show you what I mean by that. Let me read. So if I focus on this triangle right here, that I'm marking in red. This is an extension of this side, and this 28 is an exterior angle. Now, see this exterior angle, it is equal to the sum of these two angles, the two opposite interior angles. And if it's equal to the sum of the two of them, and the two of them equal, it means that each of them are 14. Right? That's what it means, you know, each of those two angles equal 14. Another way we could find those two angles is to come back right here and say total angle on a straight line is 180 degrees. And find this side, this angle right here. And then do 180 degrees minus the 28 and get this angle. Then after we get this angle, we're gonna say no, this is an isosceles triangle. But we're doing the maths the easy way. Alright? So let's do the easy way. And use external angle business I told you about. Right? So let's do it like this. Let's call those two angles alpha so we can reference them. These two angles that we want. And let's call them alpha. So I'm going to call this angle alpha and call this angle alpha as well. Alright, and then now we can say that alpha plus alpha, no, those two angles are equal alpha because isosceles triangle. So alpha plus alpha equals 28 degrees. And therefore alpha equals 14 degrees. All right, what are the reasons? First reason is that PQR is isosceles. That's why those two angles were equal. Isosceles. And the reason why them add up to 28 is that the exterior angle equal the sum of the two opposite interior angles. This exterior angle out here, this exterior angle out here, which is 28, is equal to the sum of the two angles in opposite interior angles. All right, that's a good rule to know. All right, so we can say exterior or external angle, exterior angle RQT equals sum of the two opposite interior angles, sum of two opposite interior angles. And that's the reason why we had this. Alright, so alpha is 14 degrees. I know that alpha is 14 degrees. The angle that we want, let's put that in red now. So we can say, therefore, the angle that we want, originally, the angle that we want is this angle PRT. Angle PRT is equal to 14 degrees, which is alpha plus 76 degrees. Alright, and that is 90 degrees. It is 90 degrees. The angle that we want here is 90 degrees for those reasons. All right, that's what we have so far. All right, let's put the angles that we know over on this side, so we can use it. Yeah, so we know that this angle is 14. This angle is 14. This angle is 28. This angle is 76. That's all we know so far. All right. That's what this want us to find. The next part now says angle SPT. We must find angle SPT. Next thing we want to find is angle SPT. Given that angle SRT is 145. Let's write it. Angle SRT. Angle SRT. So basically what they're saying is that all of the angle across here, so now all of this is 145 degrees. Is 145 degrees. All right. So that a 145. It means that the remaining angle right here, this piece, is 145 minus the 90, or minus the sum of those two. All right, so it's 145 minus the 14 and the 76, which is 90. So this angle inside there so is 55 degrees. All right, which angle I want? Angle SPT. Angle SPT. The angle that they're asking us to find, you know, is this angle down here. We can mark it in a different color. Angle that they want us to find, we can mark it in green. All right, we can mark it in green. So the angle they're asking us to find is this angle here. So to find this angle here, we need to find this piece and add it to the 14. That's one way we can do it. All right. Yeah. All right. So what does it tell us? They also tell us that angle PSR is 100. Angle PSR is 100. So they also told us, let's go back to the purple. They also told us that this angle is 100 degrees. All right. And so it's easy to find this angle that they want. Angle SPT. Find out the green piece here first. So it's going to be in total angle in this triangle now. Total angle in that triangle is 180. So that's going to give us the angle down here that we want. First, let's mark it. Let's mark it back in green. Let's mark it back in the green. So that angle that we want is going to be 180 degrees minus the one, well, actually minus the 180 and the 55. So this angle inside is going to be 25 degrees right here. 25 degrees. Total angle in triangle. That's going to be 25 degrees. Right? And then now the 25 plus the 14 is going to give us 39. That's the final answer. We're going to express it now. We're going to write it up so that will give the reasons. All right, so let's write it up. So the first thing is to show them how we get the 55 angle there. The first thing is that the angle SRP is 145. The total angle that they gave us minus the 14 and minus the 76. And that leaves us with 55 degrees. All right. And then now the angle of 25 degrees, I'm sure we'll get the 25 degrees now because they told us that the angle there is 100 degrees. So we're going to say angle SPR. Angle SPR is the 25 degrees that I'm showing on the diagram. Is equal to 180 degrees minus the 100 degrees that they gave us, and also minus the 55 degrees that we got in the triangle, because total angle of the triangle is 180. That's going to give us 25 degrees. And then the angle that they want now, which is angle SPT, becomes the said 25 degrees plus the 14 degrees, which is now 39 degrees. And that is their answer. Right. And that's how we get that one there. Alright? Alright, good. So let's move on. Alright, so come to this question now. Let's show it on this page. Alright, so transformation. So this question says the diagram below shows triangle ABC and its image A prime, B prime, C prime under a single transformation. So a single transformation go from this to this. A single transformation. It says describe completely the transformation. Which maps ABC to A prime, B prime, C prime. Now clearly that's not an enlargement because there's no change in size. That's not a translation because the thing translation does move the thing without turning it. Clearly we have some turning taking place here. So it's either a rotation or a reflection. And we know what we'll do to make sure it's not a reflection, or if it is a reflection, to decide if it's a reflection or not, is to check the orientation of the letters. Alright? If the orientation is reversed, then you know you have a reflection. Remember, a reflection and a rotation tend to look alike sometimes. So the orientation on the object ABC is this way, anticlockwise. And on the image, ABC is still this way, anticlockwise. So since the orientation is the same, it's not reversed, it means that it is not a reflection. So it must be a rotation, but there's some turning. So we can start work out the rotation. Rotation has an angle, a direction, and a center. So if we look, for example, on the side, BC is pointing up this way on the object. But on the image, BC is now pointing horizontally. So you know that there's a rotation of 90 degrees taking place. So you know that there's a rotation of 90 degrees. So you know that. You also know that the rotation is this direction because this was pointing up and it's pointing to the right. So the rotation is clockwise. So you know you have a clockwise 90 degree rotation so far. Next thing you want to know is the center. And I always tell the students, usually with these questions, the center of the rotation is usually the origin. So you just want to check and make sure. So you can check the distance from the origin to this point, the same distance to this point. You can see the 90 degree right there. All right, so that confirm that one. And then from A, that's the distance. And this is basically the same distance. Broken down into 4 across, 1 up. 4 up, 1 across. So the same distance. And if you check C, this is the distance to C. This is the distance to C prime. You can see the 90 degree there as well. The distance here is 1 across, 3 up. This one is so 1 across, 3 up goes to 3 across, 1 up. 3 across, 1 up. So you know that there's a rotation of 90 degrees about the origin. So that confirms it. So we can basically go and write it now. And once you do that, those little checks, you can go and write it. So we can write it like this. Triangle ABC maps onto triangle A prime, B prime, C prime by I'm going to give the 3 components and the name in your description. By 90 degrees, direction is clockwise, rotation about the origin. You always check to ensure that the components are all written there. So I've given the name. Rotation has 3 components. It has an angle, a direction, and a center. And all 3 are there. So you know that you have completed. You have to describe it completely. Sometimes they say describe it completely or describe it fully. So to describe it completely or fully, you give the name and the components. Rotation has 3 components. So you have to make sure you give the name, which is rotation, and still three components, the angle, direction, and the center. And that's it. The next part now says the translation T is 4, -5. 4, -5 means 4 to the right, 5 down. And it maps the prime triangle onto a double prime triangle. Alright, so it maps the prime triangle. This is the prime triangle. I'm going now to a double prime triangle using that translation. 4, -5. This I must draw the double prime triangle. So in other words, we must do the construction. Just draw it. You don't need to do no calculation. Just draw it. So all you have to do is transform the points. Quite easy. Right? Remember, we're doing 4, -5. That's our translation. 4, -5. So how do you do 4, -5? Do it 1 point at a time. That's the first thing. Don't try to do it all at once. Do 1 point at a time. 4 to the right, 5 down. All you have to do is move each point 4 units to the right, 5 units down. All right. So see it here, using A first. 1, 2, 3, 4 to the right, 5 down. 1, 2, 3, 4, 5. So right here is the point A double prime. It's easy as that. A double prime. All right, and then we'll do a similar thing for B. So B is 4 to the right, 5 down. See there? 1, 2, 3, 4, 5 down. 1, 2, 3, 4, 4, 5. So it's coming right here. And so that's B double prime. B double prime. All right, so we can take this out. Let's take this and write this on the other side. This is A double prime. A double prime. And we do the same thing for C. 4 to the right, 5 down. So you're gonna go 1, 2, 3, 4 to the right, 5 down. 1, 2, 3, 4, 5. So right here is where C double prime going. Right. So you see this point is C double prime. And then once you have the 3 points in place, just use a ruler and complete the triangle. Use a ruler and you complete the triangle. And that's it. Done. Easy as that. All right. Simple as that. Under the translation. 4 units to the right, 5 units down. And use blue and mark it out. 4 units to the right, 5 units down. This is 4, and this is -5. And you go down 5 to go from E to E prime. And after that, it with each point. All right. Next question. Next question now gives us this diagram. Question 6. Question 6. So that's a circle. Circle measures question. Right? He said we must take pi as 22/7 as the first thing. Take pi as 22/7. So the diagram, not drawn to scale, shows a field in the shape of a sector of a circle, center O, and diameter 28. So the diameter is 28. It means that the radius right here, from the center of the circumference, the radius is 14. So first we want to get half the diameter of the radius. All right, everything important. So this is 14. That information is 14 meters. That also is 14 meters. 14 meters. Now you can note radius R equals 14 meters. So we tend to do these questions with the radius mostly. 14 meters. It's a calculate the area of the field. So the area of the field is the area of the sector. Remember this angle inside is 90 degrees. You know? This is 90 degrees inside here. All right, so it's area of a sector formula we're using. So see it here now. Area is theta over 360 times area of the circle, which is pi r squared. Fraction of the area of the circle, area of the sector. So that becomes 90 over 360 times pi, which we tell is 22 over 7, times the radius, which is 14 squared. If we want to, we could have also recognized that this is just a quarter of a circle, you know, and just the quarter of the area. We could have done that as well. Instead of doing a 90 over 360, because 90 over 360 is still a quarter. We could have done it that way. Alright. So basically that works out to be 154 centimeters squared. That's the area of the sector if you work it out. The next part now wants the perimeter of the field. The perimeter. The perimeter of the field is the distance around it. So if you look at the diagram over here, look at the diagram over this side. Where is it? It's this length plus the arc length plus this length. The perimeter is the distance around it. Let's write it out. Alright, so the perimeter of the field is equal to the radius, 2 times the radius, let's write it out, 2 times the radius equals to 2 times the radius plus the arc length. It's equal to 2 times the radius plus the arc length. Alright, we look over here. It is this radius plus this arc length is the distance around the field. Alright, so it becomes 2 times the radius is 14 plus. Now the arc length is a fraction of the circumference. What fraction? 90 over 360 is a fraction because the angle here is 90 degrees. If to the whole circle, it would be 360 times 2 pi r. Circumference of a circle is 2 pi r. And the arc is a fraction of the circumference. The fraction is the angular fraction, which is 90 over 360. So you put in the values now. The 2 times 14 is 28 plus 90 over 360. I could put a quarter. This is just a quarter of the circumference. Times 2 times the pi is 22. 22 over 7 times the radius, which is 14. You work this out, and it comes out to 50 meters. Right. Up here, put centimeters squared, should have been meters squared. Should have been meters squared, so correct that. We're working in meters. All right, so that's that. Find some correction and correct it. All right, good. So the perimeter there is 50 meters. All right, next part. So we'll come to this question now. All right. So this question now. Hold on a second. All right. All right, come to this question now. So this clearly is a solid geometry question, right? Uniform cross section. It's an objective uniform cross section, prism question. I tell the students 3 formulae we use to guide ourselves in this question. That volume equals cross sectional area times the length. This should be the length. The sum between the 2 ends is the length of the prism, L. The sum between the 2 ends. The A is the end area, the area of the end, which in this case is a triangular end, area of the end. All right, so that will give it the volume, end area times the length. And you have an objective uniform cross section. And then now the second formula is that the curved surface area is the perimeter of the end times the length. What's the curved surface area? Is the area of the faces around the side of the object. The area of the faces around the side is called curved surface area. That formula is the perimeter of the end. The perimeter of the end will be this plus this plus this perimeter of the end would be those lengths, right? Times the length. And then we have what we call total surface area, would be the curved surface area from this. And this would have two ends in this case. So it's a plus 2 times the end area. Some objects only have one closed end, so it will be just plus A. But basically, when it's a solid object throughout, those are the three formulae that govern this topic. Them three things here govern this topic. All right. All object with uniform cross section can be governed with those three. All right. So you have to remember that. So anyway, this question wants us to calculate the area of the triangle. Now, if you look at the triangle, it's a right angle triangle, and it gave us two of the sides. They gave us 6 and the 10. So that's the hypotenuse on one of the sides. Now, clearly, this triangle is a 3, 4, 5 triangle that has been doubled to a 6, 8, 10 triangle. If you can recognize those Pythagorean triples, you're good. It means that the side that we don't have is 8. So we have the 6 and the 10. 10 is hypotenuse. The side that we don't have is 8. So it means that this side that they give us is equal to 8 centimeters. The side that they didn't give us is 8 centimeters. This side is 8 centimeters that they didn't give us. All right, and I want the area. If you put all these markings on your paper, you know, examiner will accept it, you know, as your explanation for the 8, you know, and give you your marks. These are the markings. Right, I put it as a 2 times 3, 4, 5, it's a 6, 8, 10. Circle the 8, put the 8 on the diagram, put the equal in front it, and they'll accept it. They can advance if I know it's a Pythagorean triple. It's called a Pythagorean triple. Let's call it a Pythag triple. 3, 4, 5, double to a 6, 8, 10 triangle. All right, if you want, you can use Pythagoras system and work it out to get the same answer. And then now the end area, the area of the triangle is called the end area. It's going to call it the end area. I want to use it in the formula. I want to use it in the formula up here, the A up here. I'm going to call it A from now. So the end area is the area of the triangle. A becomes half base, which is 6, times height, which is 8. And so the end area is 24 centimeters squared. Simple as that. That area is 24 centimeters squared. All right. And then now, the next part wants us, remember the end area is 28. No. It tells us that the length of the prism, we must find the length of the prism if the volume is 540. So see, you know, using the formula that says volume equals end area times length. And they're asking us for the length. Now remember, the length is the distance across these two sides. Now look at the diagram over here. This is the length, the distance from between the two faces is the L, and the end area is the area of the end right here. And the volume is the end area times the length. So we want to find the length. It means that the length now is equal to the volume divided by the end area, which you know the end area is 24, and I know the length of the volume is 540, or divided by the end area, which is 24. That tells us the length. All right, when we do the calculation, it works out to be 22.5 centimeters is the length of the prism. The distance between the two ends is the length of the prism. All right, 540 divided by 24, 22.5 centimeters done. Then I want to know the surface area of the prism. It is the total surface area we're talking about, and we just did it a while ago. The total surface area is what I want. Is the curved surface area plus 2 times the end area. We'll call the end area A. The curved surface area is the perimeter of the end. That's what P stands for, the perimeter of the end times the length of the prism plus 2 times the end area. I'm not going to go into explaining these formulas. No, we did it in class. All right, explain why it becomes the perimeter of the n times the length. Now remember over here we calculate this side as 10, as 8, sorry. This side is 8 centimeters. All right, so this becomes, the perimeter of the n becomes 6 plus 8 plus 10 times the length of the prism, which we worked out a while ago, up here as 22.5, plus 2 times the end area now becomes 2 times 24. End area is 24. You know, all the units working, we put the final unit for finish, which is centimeters squared is the final unit. All right, and you just work out all of that now. When you work out all of that, it basically comes down to the 6 plus 8 plus 10 becomes 24. So you get 24 times 22.5 plus 2 times 24 is 48. When you work out everything right here, it becomes 588. Area is centimeters squared. That becomes the total surface area. When they say surface area, they mean total surface area all the way around. That is that question. All right, that's that. Let's move on now to the next one. All right, so this one is the next one now. Question 7, the statistics question. All right. So it says, table below shows the speed to the nearest kilometer per hour, the speed to the nearest kilometer per hour of 90 vehicles that pass a checkpoint. So I want to, this is showing the speed at which 90 vehicles pass a checkpoint, all right, into the nearest kilometer per hour. All right, so these are the speeds, range of the speed, and it's a group data. These are the number of vehicles, the frequency, number of vehicles. All right, it says for the class interval 20 to 39, which is this one. As written in table above, complete the following statement. The upper class limit is the value as it appears in the table, so that is 39. Upper class limit is 39, and we can put the unit is kilometers per hour. 39 is the upper class limit. But if you just put 39 and don't put the value, that's fine. Let's put the 39. The class width. The class width is the upper boundary minus the lower boundary. Because remember, what happens is that this class can take values up to less than 39.5, and it can take values starting at 19.5. So if a vehicle going at 19.5, they're going to approximate it to 20. And any value that is less than 39.5, they're going to approximate it to 39. From 39 to 39.5 to less than 39.5, we're going to classify it as 39. So basically, that group is taking values, the class which is from 39.5 to 19.5. But I can also look at the lower limit values going up by 20. See, they're going up by 20. I know that the class which is 20. I can look at that and know. I can also look at the upper limit values going up by 20. See, they're going up by 20. Going up by 20. I know that the class which is 20. So we can get it either way. But for definition purposes, it will be 39.5 minus 19.5, which still gives you that 20. But I could just look and know that it is 20 by observation. And you can put in the kilometers per hour. If you leave it off in this case, I don't think they'll penalize you. But that is the class with 20. We know that we're working in kilometers per hour. Right? But that is the class with. It says now, 16 vehicles pass a checkpoint in no more. No, so you have 16 vehicles. This total number of vehicles, right, up to this class. Remember now, you know, the first 5 vehicles is going up to 19.5 kilometers actually. right? And then the next 11 vehicles take it up to 16 vehicles. A total of 16 vehicles pass the checkpoint in no more than 19.5 kilometers, no more than 39.5 kilometers, because that is the upper boundary for this second class. All right. So the answer is that no more than 19, more than 39.5 kilometers. The speed at which 16 vehicles pass the checkpoint. So there are 16 vehicles pass the checkpoint in no more than 39.9 kilometers per hour. 39.5 kilometers per hour. All right, because that is the upper boundary for this class. Right, so you have 5 vehicles from the first group, and then 11 vehicles in the second group. So none of them can pass in more than 39.5. All right, 39.5. None of them can pass more than that. All right, so that's that. 39.5. The next part now says, complete the table to show shown above by inserting cumulative frequency. So we basically completing this cumulative frequency column. So you basically adding up how many vehicles you have as you go along, right? So the next one is gonna be 16 plus 26. So we're gonna have 42. You put the next set of vehicles, which is 42 plus 37. And so you know have a total of 79. And then the 79 vehicles plus 9 more. The ones who go less than 80, less than 99 kilometers per hour. And so you now have 88. And then the last two, 88, plus the last 2 vehicles who go in the fastest. That gives you a total of 90 vehicles that they have in the sample. 90 vehicles. That completes the cumulative frequency column. Then it says now, on the grid provided, let's put them over here because we're going to need the values for the table. Let's put the values in here. So it is 42, 79, 88, and then 90. All right, and what we're going to need are the upper boundary values. All right, so we're going to need the upper boundary values. Let's put them in here. So the upper boundary value is 19.5, 39.5, 59.5, 79.5, 99.5, and then this is 119.5. Alright, 119.5. I'm basically gonna plot these upper boundary values against these cumulative frequency values for a cumulative frequency curve. Remember, cumulative frequency curve is supposed to show you how many vehicles were going at less than any speed. How many vehicles were going at less than any speed. And that is the data represented there. So 5 vehicles were going less than 19.5, sorry. And then a total 16 vehicles were going at less than 39.5. And a total of 42 vehicles going less than 59.5, and so on and so forth. And the graph is going to represent that. So those are the points that you have to plot. All right, on the graph. So let's go on the graph now. So the scale that we're using is 2 centimeters to 20. 2 centimeters to 20 kilometers per hour on the horizontal axis, and 2 centimeters to 10 vehicles on the vertical axis. Right? So it's 2 to 20 and 2 to 10. All right, that's on this graph. All right, so that's the graph. So it's 2 centimeters to 20. So that's 20, 40. 2 centimeters to 20, let me say, let's see right here. 2 centimeters to change, right? So it's 1 centimeters to 10. So this is 20, 40, 60, 80, 100, and then 120. Right here. These are the marks putting in the scale. Then up here now is 2 centimeters to 10, they said, right? 2 centimeters to 10, right? So this is 10, 20, 30, 40, 50, 60, 70, 80, 90 vehicles. All right, let's see what we can do now. All right, here is 0. So the first one is 19.5. 19.5 is just before the 20, right? Because let's get the scale right. Now, what will happen is that each mark is 2. So it's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Right, so 19.5 gonna actually be just before the 20, right? Right in the box before the 20. So it's estimating anyway. So just before, remember that this now is 18. So it's 2, 4, 6, 8, 10, 12, 14, 16. This is 18, you know. So 19.5 gonna be right in between here. Right, so it's just beside the 20, very, very close to the 20. Right, so on each point they're coming just before the line. So it's 5. So just before that is 5. So this is 5. So the first mark here is 5. That's the first point right here. 5. All right, the next one is less than 39.5 is 16. 39.5 is right here, going up to 16. Right here is 16. Right, 16. 16. The next one be 59.5 is right here. That one going up to 42. 40, 41, 42 right here. The next one, 79.5, going up to 79. 79. 79.5, we're going up to 79. Let's make it small so we can see. 79.5 going up to 79, which is right here. Right there. And then the next one is 99.5 here. 99.5 right here. That one go up to 88. 88 is right here. Wrong place here. 88 is right there. And then last one is 119.5. That one going up to 90. That one reach up to the 90 right here. And you're drawing a smooth curve to the point. So you go. And by the way, the value before this would be negative. The value before this at a frequency of 0 would be negative 0.5. Okay, you have to subtract 20 from each value. So from 19.5 subtract 20. If you notice all the values going up by 20. From 19.5 to 39.5 is 20. So 19.5 minus 20 will give a negative 0.5, so just before. What that means is that no vehicle was reversing at 0.5, because the negative 0.5 means that you're reversing. And since the frequency down here is 0, it would mean that no vehicle was reversing at 0.5 past the checkpoint. All right? So it's important sometimes you bring a graph down to the x-axis, previous value down onto the x-axis. Anyway, curve would basically be like this smooth curve. Don't put any ruler on it. It's a curve. And going up like that. Going up like that. It has a characteristic shape. This is what your Archimedes curve is supposed to look like every time. Must have that shape. Don't get that shape, you know that something is wrong. This shape is called the ogive, ogive, O-G-I-V-E. It's another name for the Archimedes frequency curve, the ogive. So an ogive shape. Alright, that's it. Alright, so that's the Archimedes frequency curve. It has the right shape, like that. Then now, they want us to answer some questions from it. Let's look at the questions down here. It says, on your graph, draw reference lines to estimate the speed at which no more than 50% of the vehicles drove past. Remember, down here we have the speed, you know. Down here is the speed of the vehicles, speed in kilometers per hour. And up here we have the vehicles. Up here we have the number of vehicles. Up here we have the vehicles, the 90 vehicles. Alright, so here we have the vehicles. Alright, and 50% of the vehicles is 45 vehicles. So let's use a different color for that part. Let's use a red. Alright, so 45, right here is 50% of the vehicles, right here. 45 vehicles, that's 50% of the vehicles. 50% of the vehicles. So it's almost like you're finding the median speed. Speed at the 45th vehicle travel at. So basically let's come across on the graph here. Come across on the graph. And read that value down. Looking at about 60 kilometers per hour. About 60 on that graph. So it looks like about 60 kilometers per hour. Let's almost draw the lines. Those are the lines. And they ask what is the speed? And the speed is 60 kilometers per hour. That's it. So we have drawn the lines, which is the answer for this part. And then we have marked right the answer. The speed is 60 kilometers per hour. All right, that is that. All right, let's clear off all of this before we move on. Otherwise, it's going to remain on it. We don't want that. All right, so moving on to the next question now. Question number 8. All right, so this is a pattern question. Sequence pattern question. Question says, first 4 figures in a sequence are shown below. Figure 1 is a single dot, while each of the other dots, each of the others consists of block dots arranged in an equilateral manner. So basically, you have an equilateral triangle on each side. You have 4, 4, 4, 2 on this side, 2 on this side, 2 on this side, and 3. Right? That's what you find that's happening. How did they do that? How did they get that? If I look at it, essentially, it's like they put 2 dots below this one to go from this to this. And then I put 3 dots below this one to go from this to this. And then I put 4 dots below this one to go from this to this. And so to go to the next one, I'm going to put 5 dots below this one. All right, simple as that. All right, you can make that observation. All right, like I keep adding to the base and pushing up the thing. So I'm going to draw the 5th one. So for the 5th one, as I said, it's like you're going to put some dots under here to get this one. So it's like you draw the 4th one and then you put the dots under there. All right, so let's see if we can draw a thing. Let's draw it in blue. So I'm going to put the 4 dots under here first. No, not red. I want to draw it in blue. All right, so I can put the 4 dots under here first. I put 1 here, 3 up here, so I put 2 up here, so I put 1 at the top. That right now is figure number 4. And then to get figure number 5, this is figure number 4 now. So I've drawn figure number 4, and I'm going to add figure number 5 now by putting 5 dots on here. 1, 2, 3, 4, 5. That's figure number 5. So that's 5 on this side. 1, 2, 3, 4, 5. 5 on this side. 1, 2, 3, 4, 5. And 5 on this side. 1, 2, 3, 4, 5. So keep the pattern going. Now as 5 dots on the sides. Equilateral shape. Alright. That's it. It says how many dots would there be in figure number 6? So to figure out how many dots would be in figure number 6. Now look what happens. From here to here, you add 2 dots. So you add the figure number to get this one, right? Add 2 to what is in the first one. Then from here to here, you add 3 dots to get the figure that's in this. And from here to here, you add 4 dots to get this one. And from here to here, you add 5 dots to get this one. And then to go to the next one, you'd have to add 6 dots to see how many is in the next one. But I can't say that. We'll add 6 dots. How many dots we have? We have 4 on this. We have 4 on this line. 1, 2, 3, no, 5 on this line. We have 5 on this line. Let's work it out. I like to use a formula, but let's work it out still. I like to just go and use a formula, but let's work it out and see if anyone use a formula. You have 5 on this line, 4 on this line. You have 3 on this line. You have 2 on this line, and you have 1 on this line. And the next figure, you're gonna have 6 on that line. So this kind of adding up all of those. All right, so it's foolishness. That's 5.
21.
21. 21. All right, 21. What is the reasoning? I like to go and use a formula, and that's why I was working it out. All right. So it's 21. I keep adding the number that's based on the figure number, and we can see that. All right. So what we have before plus the 6 more. All right. So let's go. Take this off. I would understand the reason, but I like to use a formula doing that. But let's continue. Next part now says next part says we have to now complete the table by observation. This is where now I drop in my formula because I'm not doing it no hard way. I'm gonna put in my formula first. Easier. So question says the table below refers to the number, refers to the figure and the number of dots in each figure. Study the pattern shown, right? So it's half, and this figure matches the figure number every time. You can see that. And then this first figure also matches the figure number, and they're always adding 1. All right. So based on that observation, you can get a formula with the n. So with the n, it becomes half times the figure number, which is n, times the figure number minus 1. That's what it becomes. It simplifies to half n minus 1. If you just observe. This is not the type where you're adding the same
Sorry, you
number
mean
each time.
plus.
Huh? Oh,
Plus
plus, yeah,
1.
plus. Yeah, plus 1 times plus, not minus, plus. Good. So this is not the type where you're adding the same number of items each time. So you can use the method that we spoke about previously for those other ones that they said more often. All right, and once you have that formula, it's easy to fill out now for the 11. Right? But I want us to complete the table, you know. So complete the table right here. So I work out the formula first. So it's gonna become half times 11 times 11 plus 1. That's what you're going to do on the table. And when you work it out, you're gonna get 66. 66, you're gonna get. right? 66. This is gonna be 12. Then half of the 12 is 6, and 6 times 11 is 66. All right, so that is that. Next part now says determine which figure in the sequence has 210 dots. So all we have to do is make the half n plus 1 equal to 210, and we use a reasoning method. So it means then that n times n plus 1 equals 420. So basically then is the product of two numbers, two consecutive numbers must equal 420. You know? That's what you want, you know. The product of two consecutive numbers to be equal to 420. So to find those two numbers quickly, you know, what I would do is find the square root first of 420. So I square root 420 and get 20.4 something. So I mean that one of the number is 20 and the other number is 21. Right? Simple as that. Right? I can work out on the side and show you. I want to find the product of two consecutive numbers must be 420. And let's say I can't figure out what they are right away. You want to use a reasoning out method. What I would do is two numbers too close together. So I would do the square root of 420. And that will give me 20.5. So it means that the two numbers are on either side of the 20. So one is 20. You come back then and I see that is 20 times 21, as is equal to 420. And that tells me that my figure number is 20. And n equals 20, so the answer for that is 20. Right? So the question says determine the figure. Right? That says figure number 20. That's it. All right. Next part now says write a simplified algebraic expression for the number of that in terms of n. We have it inside here already. Right, so we don't have to waste time. The d equals half n plus 1. We have it there already. Simplify. And so show that no diagram has exactly 1,000 dots. Show that no diagram has exactly 1,000 dots. All you have to do is put the half n plus 1 equals 1,000. Now remember, n has to be a whole number, you know. So you're trying to see if there's a whole number n that will satisfy this equation right here. Now this will reduce to n times n plus 1 equals 2,000. And then I do the same kind of work a while ago and see which two consecutive number close multiply together going to give me 2,000. So I'm going to look square root of 2,000 thing over here again to check it. All right, so I'm going to do it and show you square root of 2,000 now. Root of 2,000 and see if that would work. All right, so square root of 2,000, that is giving me 44, that is giving me 44.72. So I'm going to test if it is 44 times 45. And test if it's 44 times 45. All right, 44 times 45. So 44 times 45 is actually equal to 1980. All right, so don't reach 1,000. If you go to 45 times 46, you jump over the 2,000. See, 45 times 46. You got 2,070. So therefore, there's no n that will cause it, the two consecutive numbers, to be equal to 2,000. Right? So there's no whole number that is such that is the case. Right? And if you do this little work and show them, they'll understand. So you can write the answer here and say, back in blue. And so therefore, there is no whole number There's no whole number. Right? By telling them that, they'll give it a marks. Maybe I want to write more, but they get the picture. There's no whole number that will satisfy this equation there. No whole number. No whole number solution. And therefore, there's no number that could. It has to be a whole number, or a natural number. Because remember, the number of figures, figure number has to be a whole number. So there's no whole number solution by you showing them. You go to 45, 44, you get 1980. And if you go to 45, you get 20,000, 2070. So there's no whole number that will give you 2000, basically. All right, so that completes that. Next question. Question 9. All right, so question 9 gives us this velocity time graph. So the velocity time graph below. Let's go down here. On this one as well. Case we need the graph. All right, so it says the velocity time graph shows the motion of a cyclist over a period of 40 seconds. All right, it says calculate the gradient of OA. Now remember, gradient is acceleration. All right, so the gradient of OA is really the acceleration. All right, so you can say acceleration on the OA segment is rise over run. It's just a rise over the run. All right, which the rise is 10 and the run is 25. All right, 10 over 25, and that becomes 0.4. I put the correct units, So it's meters per second squared. So it's meters per second squared. Meters per second squared. When you calculate gradient, you actually calculating acceleration. So that's the rate at which the speed is increasing. The speed on the first segment here is increasing at 0.4 meters per second. Right, meters per second squared, 0.4 meters per second. So every second the speed increased by 0.4 seconds, 0.4 meters per second. Then I want the gradient of AB. It's a horizontal line, so the gradient is just 0. So on AB, the acceleration, which is the gradient, acceleration, which is also the gradient of AB, is equal to 0 because horizontal line. There's no rise. Acceleration is 0 because going at a constant speed. All right, that is that. So the next part now says complete the following statements. The cyclist started from rest, which is right here. Look over this side now. Look over this side. It started from rest where the speed is 0. Right, and the cycle started from rest where the speed was 0 meters per second. And instead of increase its speed by increasing speed by the rate of acceleration, which is 0.4 meters per second per second. So each second here per second. That's why the acceleration I'm talking about. 0.4 meters per second each second. So 0.4. The acceleration that you calculated is the answer right here. 0.4 meters per second each second for the first 25 seconds. That's here. First 25 seconds. Right? During the next 15 seconds, we're talking about here now. During the next 15 seconds, his speed remained constant. That is, his acceleration was 0 meters per second squared. It says determine the average speed of a cyclist. Determine the average speed of a cyclist over the 40 seconds. Well, the average speed is the distance over the time, and the distance is the area under the graph. All right, so let's do it here. So the average speed equal the distance that he travels over the time that he took. distance over time. Remember now that the distance is actually area under the graph. That's area for the time. Distance on a velocity time graph or on a speed time graph is area. So basically I want the area under the graph now. Right? So let's work it out here. So we can write it like this. The area is the area of the, you can look at it as the area of a trapezium. So a trapezium with the parallel sides. This side is 40 and this side up here is 15. And then this side between the parallel sides is 10 here. That becomes the area. After some of the parallel sides times the distance between the parallel sides. Right? As I said up here. Right, up here is 15. Down here is 40, and this between them is 10. So let's do the calculation over here. So it becomes half the parallel sides, half the sum of the parallel side, which is 40 plus 15. Times the sum between the parallel side, which is 10. That's going to give you the distance, and you divide that by the time, and time is 40. Total time is 40 anyway. So this up here is the distance, which is the area, and the distance down here is the time. When you write that out to the calculator, you're going to get a final answer of 6.875 meters per second, because speed is in meters per second. Someone can check that for me. So it's 5 times bracket, that's 55, close bracket divided by 40. Yes, 6.85. 6.875 meters per second is that average speed for the whole journey. All right, next question. All right, so part B now says consider a pair of simultaneous equations, right? This one is a curve. You can see it's a curve because of the square term and the xy term. This one is a line because it can be written in the form y equals mx plus c, xy plus x plus y equals 3 is a line. It says without solving, show that 1, 2 is a solution to the pair. So if 1, 2 is a solution, it means that 1, 2, the point 1, 2 satisfies 2 equations, right? So at the point 1, 2, the x is equal to 1 and the y is equal to 2. So you're going to test them in the line now. You're going to test them and see if they satisfy the line. So you test them in the curve first. Which is x squared plus 2xy, right? And see if it equals 5. That works out to be 1 squared plus 2 times 1 times 2. And that works out to 5 actually. So yes, this one passed the test. And you're going to test it in the line, which is x plus y. If it is true, then x plus y will be 3. That is 1 plus 2. 1 plus 2 is actually equal to 3. That's what the line is saying. And so both of them pass the test, and that is therefore shown. Because they both satisfy. Without solving the equation, show that they satisfy the pair of equation. Yes, because the values work in the two equations. All right, the values work in the two equations. They satisfy the two equations. The xy value, when you put xy values in the equations, they work out to be the values that they tell you that it's supposed to work out in both cases, and so that is true. Then it says now solve the pair of equations to determine the other solution. Remember, one solution is 1, 2, this point. We're trying to find the other solution. When you proceed to solve it, you're actually going to get two solutions, right? So let's solve them simultaneously. Basically, solving them simultaneously. Let me go down here and show the two equations on this one. on this side, right? So the two equations we have is x squared plus 2xy equals 5, and we have x plus y equals 3, and this equation really becomes y equals 3 minus x. This is the curve, and this is the line. We're going to use a substitution method. It's usually easier to use a substitution method. It means a different color for this arrow. So that becomes that. All right, so that is the line, that is the curve. So we're going to solve by substitute for y. We're going to substitute the line into the curve. I want to find where they intersect, so put them together. Substituting for the y. And so the curve becomes x squared plus 2x. Where the y is, going to put this now, where the y is 3x minus 3 minus x. 3 minus x. And that now, this says equal to 5. All right, and you're going to write this out in a standard form. It's a quadratic, it's a disguised quadratic. So write out in a standard form. So it becomes x squared plus 6x minus 2x squared equals 5. And we're going to transpose everything onto one side of the equation. I want the x squared term to be positive, so I'm going to carry everything over this side. All right, carry everything over this side. So when we carry this over here, it becomes positive 2x squared, and we carry this over here, it becomes minus x squared. So 2x squared minus x squared over that side, giving me a positive x squared. So I'm within x squared. Carry over the 6, I get minus 6x. Minus 6x. And the 5 is already over there, so that's a plus 5, and the result is equals 0. Instead of putting it there, I can put it here, equals 0. And it's a matter of factorizing this now. When I factorize this, I remember one answer was x equals 1. So I get x, 1 and 5, minus. That's what you're going to factorize. All right? That's what you're going to factorize. You can test it. Far product is minus 5x, and near product is minus x. Minus 5x and minus x will be minus 6x. So no, say factorize good. So one answer is that x equals 1, the other answer is that x equals 5. This is the one that we know already. All right, so let me use the red ink now just to finish it up here. Or run out of space. So I'm going to use this one now. This is the other solution. This is the other point. And then now we're going to substitute in the line equation. I'm going to substitute in the line equation. So the other point is where x equals 5. And the y is going to be 3 minus 5. If you substitute in the equation, the y is going to be negative 2. And so the other point is 5, negative 2. This right here is the answer as the other point. The other point they wanted. This is the first point that we had already. This one. That we had that one already. All right. So that is that. So the other point is 5 minus 2. You basically solve it, and then you don't bother include the 1 because you know the 1, 2 already. So you're really working on the other point, which works out to be 5, negative 2 is the other solution. All right. Let's go to question 10. All right. So question 10. Question 10 is a circle theory question, right? All right, so let's go. Remember your rules, 7 rules: center rule, diameter rule, same segment rule, tangent and radius rule, 2 tangents rule, side quadrilateral rule, tangent and chord rule. All right, so that we're doing class all the time. All right, this question says PQR and S are 4 points on the circumference of a circle shown below. They give us that one angle, which is 58 degrees. It says using geometric properties of a circle. Those are the rules we're talking about. We are to of a circle. Give reasons for each step in your answer. Determine the measure of angle SPQ. SPQ. What is this one? SPQ. So the first one is that we're going to use a cyclic quadrilateral rule. Opposite angles in a cyclic quadrilateral are supplementary. So this angle down here is 180 minus this one. All right, that's obvious. Cyclic quadrilateral. So see here, angle SPQ will be equal to, let's use the blue. Angle SPQ is going to be equal to 180 degrees minus 58 degrees, which then works out to 122 degrees. The reason for that is that opposite angles in a cyclic quadrilateral are supplementary. Supplementary means that they add to 180 degrees. And then that's a cyclic quadrilateral, right? That I marked before. It's a cyclic quadrilateral. Alright, so worked out that this angle down here is 122. Let's put it on the diagram on this side so we can reference it. This is 122 degrees. That's what we know so far. Next thing I want is angle OQS. Angle OQS, that's this angle. Here, the one now. But a sector triangle is an isosceles triangle because this is a radius and this is a radius. Right? That's a radius and that's a radius. So this angle and this angle are the same. So if we can find this angle, we're good. Which is what we're going to do. All right. So what we're going to do, we're going to say this angle down, this angle here we're going to find first. Angle at center rule. So we're going to say, firstly, we want to find that angle at the center, angle QOS is equal to 2 times 58 degrees, which is 116 degrees. And the reason for that is that angle at center is twice angle at circumference. Let's write it. Angle at center is twice angle at circumference. That's the reason for that. The angle at the center of the circle is twice angle at circumference. Right? And that's something by the same chord or by the same arc. So the angle inside here is 116, 116. And then now that is an isosceles triangle. So we're gonna say now, angle that we want now, these two angles are now equal. This angle and this angle are now equal. Because 180 minus 116 divided by 2. So we can write it now. All right, the reason angle OQS is 180 degrees minus the 116 degrees. I divide it by 2 because each of those angles down here are equal. And so that works out to be 32 degrees. 32 degrees. Got it going up to 64. And the reason for that is that triangle, I can say total angle in isosceles triangle. Total angle in isosceles triangle, and isosceles triangle is OQS. Total angle isosceles triangle OQS is 180 degrees. That's what they're telling you. It's an isosceles triangle and total angle is 180 degrees. That's how we get that answer. All right, that done. Next part. So the next part now is a bearing. So Let's come over here. Okay, erase, no problem. Over here now. It's bearings. That's in the north line, I know it's bearings. Alright, now bearings are angles in the horizontal plane. Angle through which you have to turn to the right after facing north first is the bearing angle, right? Remember those basic things. Alright, so this question says a ship leaves port A and sailed 52 kilometers on a bearing of 0.44 degrees to port B. So what it basically saying is that from here to there, the bearing is 0.54 degrees. Alright, so let me put the drawing on this diagram over here so we can see it. So what I'm going to do is I'm going to extend this line, the north line up here. And the bearing I'm talking about the angle to which you have to turn to the right to face B after facing north first. So that is the bearing angle that I want. Alright. So extend the north line. Let me draw properly. And then this going to be 0. What did I say? 44? 0.44 degrees. Angle to which you have to turn to the right. So that angle is 0.44 degrees, right? And then we said the ship changes its course and sailed to port C 72. Oh, this was 52 kilometers. All right, yes, 52 kilometers. 52 kilometers. Then it sailed 72 kilometers. So over here now it's 72 kilometers. And let's write that better so we can see it properly. 72 kilometers. And it go on a bearing of 105 degrees. So again, I face north first right here. And the angle to which I have to turn to the right is 105 degrees. So that's 105 degrees. Turn to the right. So that is the bearing angle from B to C. That. All right. It says on the diagram, draw the scale, label the known distances traveled and the known angles. So basically, I've done it over here. All right. So this is what I put on the diagram over this side is what we go on this diagram here. All right. Can put them on still. Let's put them on over here in blue. So this will be 52, sorry, kilometers. This will be 72 kilometers. This angle is 105 degrees. This angle is 105 degrees. And this angle, extend this line a bit. This angle is 44. It's 44 degrees is the angle. The bearing is 0.44, but the angle is 44. Because bearing must be written with 3 digits. Add it up first. 44 degrees. Alright, so that's what we have so far. North line. Alright, so that's the first part to label it up. So now determine the measure of angle ABC. That's the angle right here, the one, no, angle ABC. Alright. Well, there are a number of ways that this can be done. Alright, what we can do, we can break this angle down here. Use a Z angle on this side. Let me show you. Alright, I want to find this angle now across here. We can break this angle down here and then use a Z angle and say this angle inside this is 44 degrees. And then on this side, total angle of straight line is 180. And therefore, this piece over here is 180 minus 75. 180 minus 105, which is 75 degrees. 75 degrees. Can be done that way, right? And so you get the total angle across there now will be the sum of those two. Total angle over here now with the sum of those two. 75 plus 44, which is 119, 119 degrees. Look over here now, I show you another way we could do it. But we could say that these two angles are internal angles. These two angles, this angle and this angle, two of them are internal angles. Angle between the parallel sides, the U angles, are supplementary. So therefore, this angle up here would be 180 minus 44, 180 degrees minus 44 degrees, which then would be 146 degrees. Right? 146. No, 146, 136. 136, right?
Yes, sir.
136 degrees. And then we can say total angle around the point B now. Total angle around the point B now is 360. Right? And therefore, the angle inside here now that I want, let's call it theta reference. Theta would be 360 minus the other two, minus the 136 and minus the 105. Because total angle around a point is 360. And you will see that you get the same angle, 119 degrees. So you guys can check that. But see that? That's another way you could have gotten it. Alright, so that's another way you could have gotten that angle. Alright, so in any case, that is it. So you can put it down here now. Angle ABC would be 44 plus 75. Use Z angles and then we use total angle and straight line. Grade angle first. 119 degrees. Alright, that's that. Alright, next part. So we can work with the diagram over here. The next part now, so we must calculate the distance AC. So come back to this now. Remember the angle in between here is 119. You know? So we're going to use cosine rule in this triangle now. Cosine rule in the triangle here. And we have two sides and an angle between. So we're going to use cosine. So we're going to say over here now, cosine rule for AC. Using cosine rule. It's a triangle that is not a right angle triangle, so we have to use cosine rule or sine rule. So this one is the cosine rule because we have two sides and an angle between, which is 119. So cosine rule for AC, and it goes AC squared equals this side squared plus this side squared, 52 squared plus 72 squared, minus 2 times the product of the two sides. 2 times 52 times 72 times the cosine of the angle between them. And the cosine angle between them is 119 degrees. Put all of that in the calculator and you get the square root of whatever that works out to. And then you will get the final value. Alright, you will get the final value there. I am getting 11518.25. And you're gonna square root that to the nearest kilometer I want. So you don't put a decimal. The nearest kilometer, nearest whole number. I'm getting 107 kilometers. So we now know that this side is 107 kilometers. Alright, we now know that. Next part now says, to show that the bearing of A from C from this point. Remember, bearing is always measured from position. Bearing of A from C is 260. I always tell the students, if you want the bearing from this point, the angle inside the triangle at this point, let's call it alpha, will more than likely play a part in the calculation. And the bearing angle that they want, A from C, right? The bearing of A from C is the angle when you're at the front position C, angle to reach up, turn to the right to face A, which is that angle I want. That's the angle that I want. And how can we work this out? Number of ways we can work it out. We can use internal angles or we can use Z angles. We can break this and use total angle and straight line to here. And then this is a Z, so we need this angle up here. So it's too much work that. So there's an easier way. It's too much work. Let's do it another way. Alright, so we're not going to bother to break it. Because we know this angle up here, so these two angles are U angles. Let's extend this line and show it. Let's extend this line. Yeah. Alright, so that was saying now. Oh Lord. It's gone. Alright, so we have this as 72, right? 72 kilometers. Call this angle alpha. What I was saying is that, let's erase this. It's just bigger than I want it to be. Anyway, this is 150, 105. Right, and this is 72. Now these two angles are supplementary angles. These two angles are supplementary angles. So on this one, got the angle between the two parallel sides, U angles. Right, so therefore, I don't want, see, every time I touch it, just erase it with too much things. It's erasing too much. I can't control this thing. Anyway, let's mark it back again. Alright, so this is 72 kilometers. And I'm saying those two angles are supplementary angles, right? So it means that this angle right here, so this angle right here, so this angle right here is 180 degrees minus the 105 degrees, which is 75 degrees. That angle here. This angle inside here is 75 degrees. And then we can go back now and say total angle around the point. Now we're trying to find this angle phi now. Let's call it phi. We're trying to find that angle phi. Right? And the angle inside the triangle, we're going to need it. So we're going to find the angle phi is that the phi that we want, the bearing angle that is phi that we want to show is 260, will be 360 degrees minus the 75 at the top minus the alpha inside the triangle. So our aim is to find the alpha. Well, to find the alpha, we need to use this was what? This was 119 up here. 119. Right, so this angle inside is 119 degrees. So because we know our angle and side opposite each other here, we can now use a sine rule. We can now use a sine rule to find the alpha that we want. Alright, so to find the alpha, we want to use a sine rule. So I use a different color for the alpha right now. So I want to say sine rule. No. I want to say sine rule for the alpha. Sine rule for alpha. This is going to be sine of alpha over the side opposite alpha, 52. Here, the side opposite alpha is 52 equals sine of the 119 that we know over the side opposite the 119 is 107. Alright, that's what we're going to use. And then the alpha, the sine of alpha is going to be multiplied by 52 over here. It's going to be 52 sine of 119 degrees over 107. Alright, and so the alpha is going to be sine to the minus 1 of whatever that is. And when you work it out, alpha is going to be 25 degrees. When you work it out. Alright? Sine to the minus 1 of whatever this is comes inside here. Alright? And therefore, come back to this now. This comes back to the bearing angle phi is 360 degrees minus 75 degrees and also minus 25 degrees. So it's really 360 minus 100, which is 260 degrees, which then is the angle shown. It is shown. Alright, hope you understand. You need to go and work this question over again, guys. That's what I need to do. Work it over again by yourself. Alright. Alright, so let's go to the next question. The last one. Matrices and transformation. Let's go down on this. Alright. Done. Alright, so matrices. Transformation and vectors. This question said the matrices A and B are such that, and give us those proofs. Show that they may show by multiplying A and B that AB is not equal to BA. In other words, matrices multiplication is non-commutative. That's what it means. AB is not equal to BA. Alright? So let's go. Let's use the blue ink and show by multiplication. So first we're going to calculate the AB. So AB will be equal to the 3, 2, 5, 4 times the B, which is 4, 0, 3, negative 1. And remember, all multiply matrices, multiply the rows of the first matrix by the columns of the second matrix. All right, so let's work out those values. So that's going to give us a 2 by 2 matrix with 4 values here. Already know. The first value here that we want is first value that we want. Right? Is in the first row and the first column. And therefore, to get that value, we use this first row with this first column, multiply them. First element by first element, second element by second element. So it's 3 times 2 is 3 times 4 and 2 times 3. First element by first element, second element by second element. 3 times 4 is 12, and 2 times 3 is 6. Then this element next that we want is in the first row, second column. So I'm going to use this first row with this second column. All right. So it is the 3 times the 0 and the 2 times the 1, the negative 1. So 3 times the 0, 3 times the 0 is 0, and 2 times the negative 1 is negative 2. Negative 2. And this element here now is in the second row, first column. So we use this second row, this first column. And now we'll do it. Put the first element by first element, second element by second element. First element by first element, second element by second element. So it's 5 times 4 is 20, and 4 times 3 is 12. And the last value here now that we want is the second row, second column. Second row, second column. First element by first element, second element by second element. All right, so it is 5 times 0, 0. Let's widen this a bit. So 0 minus 2. And this now is 5 times 0 is 0. 4 times minus 1 is minus 4. So basically this works out to be 18 minus 2, 32 minus 4. That is AB. Now we can say no, that is AB, not AB. Now we can say BA no, so we can say and BA no. BA would be equal to 4, 0, 3 minus 1 times 3, 2, 5, 4. And that's going to give us a 2 by 2 matrix as well. I'm going to record the first value, which is this row times this column. All right. So it's going to be 4 times 3 is 12. 0 times 5 is 0. And see, they're already not equal because this equals 18. I'm going to mark it. This first value equals 18 and this first value equals 12. And they are not equal. I don't have to calculate anything else. So I can say therefore AB is not equal to BA. I could write here so. Not equal to BA. Not equal to AB. The BA that I'm trying to calculate here. This is right, BB should be BA. BA. The BA that I'm calculating here is not equal to AB because the first value not equal. So when one value not the same, it means that the matrix is not the same. Basically, that's it. They're not equal. You don't have to do any further. Once one value are the same, it means that they're not equal. Next part wants us to find a to the minus 1. All right. So remember now, a to the minus 1 equals 1 over the determinant of A times the adjoint matrix of A. And so it equals 1 over the determinant. Now what is A? I can write A over here. Remember that this is A. It's A here. And the determinant is this product. Mark it. The determinant is this product minus this product. The first diagonal minus the second diagonal product, right? And so it is 3 times 4 minus 2 times 5. Multiplied by the adjoint matrix. Now the adjoint matrix is obtained by interchanging these two. So you get the 4 up here, the 3 down here. And then you leave these two where they are and just change the sign. So you get -2, -5. All right. And this under here really works out to 2. Really works out to 2. And so this is simply equal to half of 4 minus 2 minus 5, 3. And you can put that as one single matrix and say a to the minus 1 equals 2 minus 1 minus 2.5, 1.5. That becomes the matrix a to the minus 1. All right. Next part now says write down 2 by 2 matrix represented by a times a to the minus 1. That's the identity matrix you're supposed to know. A times a to the minus 1. That's why I'm saying write it down and you're supposed to just know it. Is equal to the identity matrix, which is the matrix which is similar to number 1. 1, 0, 0, 1. That is that matrix. 3 marks for that. 1, 0, 0, 1. Let's write it down. Don't need no calculation. All right. That's it. So I'm going to come back over here and put what we have. So worked out over here that a to the minus 1 is equal to half bracket 4 minus 2 minus 5, 3, which then is also equal to 2 minus 1 minus 2.5, 1.5. All right, we're going to use that. Once you ask for the inverse of A, you generally ask you to use it somewhere else in another part. So let's go. All right, so down here now, they said, write the following pair of simultaneous equations and matrices form. So what you want to do when you're doing this now, the first check that you have x value followed by a y value in the first equation and x value followed by a y value in the second equation. That is the case. You don't have to change anything. So this is going to become a 2 by 2 matrix times the column matrix xy, because you have x value followed by y value, equals a column matrix 1, 5. The 1, 5 comes from here. All right. And then the values that go in this matrix are the coefficients up here, which now are 3, 2, 5, 5, 4. And you realize that this matrix really is A matrix, right? If you look back up here, this matrix here is really A. All right, that's how it's gonna become. So this matrix, I can put that in red and say IE, that is really A times XY equals 1, 5. So this question is going at the inverse, and I'm asked to find the first part. And asked to use it in the second part. That's what I normally do. And I'm going to ask you to calculate inverse twice. Right? So once you calculate it once. So this is really the matrix A times XY equals 1, 5. All right, but this is the answer, you know, to write the matrices form. That is really the answer for this part. But I must recognizing that this first matrix is really the A matrix. All right. All right. So the next part now says this is write the solution of your matrix equation in B as a product of two matrices. What will be the solution? In other words, what will this work out to be? XY. Now, based on this, starting with saying AXY equals 1, 5. All right. Let me just show you once again what happens here. We'll get the final result. Let me space this out so they can see it. All right. So this is equals 1, 5. Now what happens is that you have this equation, right? And you want to basically move the A. So you multiply both sides by A to the minus 1, right? Or you have to multiply. But matrix multiplication is non-commutative. You have to multiply A to the minus 1 in the front. So you basically multiply A to the minus 1 times this side and A to the minus 1 times this side. That's what you're basically doing. So you basically then multiply A to the minus 1 here. You also multiply A to the minus 1 here. Because if this matrix equals this matrix, then A to the minus 1 times this is equal to A to the minus 1 times this. That is the concept. All right? But what happens now is that the A to the minus 1 times A is really equal to the I matrix. So you now get the I matrix, which is what we got up here a while ago. The 1, 0, 0, 1 that we got on the previous page. This I matrix, which operates just at the number 1. Right? That's the I matrix times the XY now equals A to the minus 1 times the 1, 5. Right? And then the I matrix times that is just give about the XY, because the I matrix is just like the number 1. It behaves just like the number 1. It's going to give you about the same matrix. So this side then becomes just XY equals A to the minus 1 times the 1, 5. And that's what they want, the solution. So the A to the minus 1 is this thing over here that we calculated. Right? And so as a product of the solution, as a product of two matrices, would basically be that XY is equal to the inverse matrix, which is the 2 minus 1 minus 2.5, 1.5. Let's put this out a bit more to the right. Minus 1 times the 1, 5. And that is your solution expressed as a product of two matrices. That is your answer right there. The solution expressed as a product of two matrices, as a product of two matrices. That's your answer. They don't want you to solve it, you know. They didn't ask to work it out. They just write as a product of two matrices. See there. product of two matrices. So that is the answer. All right, I didn't want to solve it this time. All right, so that's what I put in red up here is what is happening behind the scenes. All right, and that's what normally what we normally do. Right over here, what we normally just say a times xy equals the 1, 5. I'll just jump and just write the xy equals a to the minus 1 times 1, 5. If I could transpose the a over here. All right. So this guy, that's one day I'll show you something else with the matrices. All right. If you have to multiply behind instead of in front, I'll explain one like that to you one day. Explain the concept of it. But that is it for now. All right. So that's what is happening behind the scenes. Let's go over the last part now, I'm sure, which is our vectors. Let's go down here. What time is it now? You guys must be tired. Oh, we're not it for a while. That's what it is. All right, so this question or the vectors question. It says the vector position vector point P and Q relative to an origin O. OP equals 4, 3, and OQ is 5, 0. All right, so this is P and this is Q, and these are their position vectors. All right, so basically what it means that this point really is a point 5, 0. This point is a point 5, 0, and this point up here would be the point 4, 3 in coordinate geometry if they were to put in the x and y axis. Right? But they're not showing that. Anyway, it says the diagram below shows that PR is 3OP, and what I normally do is put information on the diagram so it's easy to work out. So the PR segment right here, they are telling us that it is 3OP. 3OP. Okay, I'll put the vector on it because in same direction as OP here. So if that is 3OP, means that overall is 4OP. Because you have OP here and you have 3OP here. So overall is 4OP. So based on that information, right, we can write from that information that OR is 4OP. Based on what they have said. 4OP. OR is 4OP. And they also said that QS is 3SQ. See there, QS has 3SQs, three OQs on it. So QS has 3 OQs on it. Same thing. This is 3 OQs. So overall is 4, 1 year and 3 years. Overall is 4 OQs. So we can write that as well. That OS is 4 OQs. Right, and we know what OP and what OQ is, so basically making it easier for us, for ourselves. All right, 4 OQ, we're just gathering information now, right now, before we start answer questions. All right, so that's what we know. Then it says now express in terms of vector XY, OS. And so that's it. OS is 4 OQ. As easy as that, we worked out here already. We're reading it out already by putting information on the diagram. And so it's 4 times what OQ is, which is 5, 0. 4 times 5, 0. So it becomes 20, 0. Easy as that, 20, 0. Hold on a second. All right. All right, let's continue. That is finished. No, then I want PQ. PQ. Now, since we know the position vector of P and we know the position vector of Q, we can find PQ by doing O times the last minus O times the first. So PQ is OQ minus OP. This is the last, this is the first. It is O times the last minus O times the first. That's the formula. O times the last minus O times the first. The OQ is 50 minus the OP is 43. And so that works out to be 1, -3. What it means is that we go from P to Q, we go 1 this way, 1 this way. From P to Q, we go 1 this way, and -3 that way. 1 -Q, 1 -3. That's what it basically means. Alright, I guess the units kind of scale kind of messed up, but don't worry about it. But that's what it means, right? 1 -3. Then the next thing I want is what is on the next page. All right. On the test on that last part. Next thing I want is RS. Right? Remember we know OS and OR. Now let's go back and see what they were. All right. Let's write them over here. We worked out that OS worked out to be 20, 0. Let's just work out what OR was. OR was equal to 4 times OP, which will be 4 times the 43, which will be 69. All right, so go back to this now. I want RS, and RS is simply now equal to OS minus OR. And so the OS is 20, 0 minus the OR is 16, 9. 20 minus 16 is 4. That's right. Let's check this again. No, this is not 9, this is 12. 4 is 12 over here. This is 12, 4 is 12. Right. That is 12. So this is 12. So it becomes 4. 0 minus 12 is -12. Then it says state 2 relationships between PQ and RS. Once you ask for a relationship between lines, this is that they are parallel, we have to show it, and the relationship of the length of the lines. So let's write out what we know. All right, we worked out that the PQ on the first page, let's go back and see what it was. The PQ was 1 -3. PQ is 1 -3. And the RS is 4 -12. So basically you can see that this one equals 4 times this one. That is pretty obvious. This one bigger, the RS bigger by 4. So we can write that. Right? RS is 4 times PQ. RS is a bigger one. It is equal to 4 times PQ. This means that they are parallel. So one property, 2 geometry relations, one relationship that they're parallel. RS is parallel to PQ. This means parallel. And the second thing is the relationship of the length. Right? So RS is 4 times PQ. And that is the end of this test. 4 times PQ in length. All right, guys. That is the end of this paper. We have down to 9 people. Thank God record. Hopefully people will go and watch the recording. All right. Hopefully. So let me stop the recording now.